Live streaming is on. Okay. So what you want to be doing, hopefully you've downloaded the worksheet, which is on the next page, and then come back to the Canvas page and read those first two boxes. I'm going to check attendance, and then I'll be right back to go over we're going to start filling out that worksheet top, but we're going to do it together. Okay, we're missing. Is there anybody who was not able to download the worksheet? Yes, that's the worksheet that you want, Cell Transport Review Worksheet. That's it. All right, so just have that handy, then come back to the page, look at the first video at the top and the information about passive and active transport, and I'll be right with you as soon as I do attendance. Mm, which I don't seem to be able to get to go. Mm, Okay, Landon. Missing. Okay. Oops. Wrong thing. All right. Back over here. Actually, I had a video for you and it wasn't cooperating with me. Let me try one more time to get it to go. I had a Nearpod video for you and it would not launch any better than my Zoom was launching this morning, but we'll see. Try again. Everything seems to be feeling better. Okay. It's feeling better, so I'm going to send you the link for the Nearpod. Let me send it to everybody first. All right. All right, so join me on this Nearpod, please. All right, I also have it on the share screen. She's going to ask some questions, and so it'll pause, and you can respond accordingly.
I'm Lorena, and this is a cell. All cells have a membrane, and that membrane is selectively permeable. They let some things in and keep others out, sort of like a bouncer at a club. Hey, no jeans, please.
Okay, so I'm going to put this over here. All right, so take a minute to answer those questions, and then I'll look back. And as you can see, it's going to tell me whether you answered or not. So please participate. So it said she just called the cell membrane a bouncer. Okay. In addition to being a bouncer, well, let me back it up a little bit. It says it illustrates selectively permeable. Selectively means that it allows some things in and other things out. Okay, like a bouncer will stand at the door and say, you don't have a pass, you can't get in. That's what the cell membrane does. So it's asking you, what else do you think of that some things that let things in and not other things? So think about other things, maybe kitchen appliances, things that you know of that will allow some things in and not others. All right. And you need to be typing an answer because right now it says no answers. Okay, I'll keep it blank for a minute. I'll put a timer on this. Everybody take 1 minute to answer the question. And then we'll go on after we review the answers to the question. All right, let's see. I only have 2 answers, folks. Everybody's supposed to be working on this. All right, thank you, Malik and Zyla. It says a man gate. That's a good one. Is the gatekeeper. So if you have a gate, coffee filter, that's a good answer. Gravel pours through. Okay, good. That's a good answer, Ariana. Thank you. All right, everybody's supposed to have an airport security. That's good. They let some people in. That's a good answer, Natalie. All right, come on, folks. Everybody has to offer an answers. Try not to repeat what's already up here. So we have airport security. We have okay. Piper said windows. Let some things in. Okay, that's good. Ariana has gravel and porous materials, water filter, purifier. All right. All right, Kashan, a door. Okay, thank you, Maxwell. I was just about to call you. Maybe PlayStation. Interesting, interesting. All right, Kashan, what happened? We don't have an answer. All right, so these are good answers. These are good answers. So we have, and it's kind of more like a coffee filter purifier. So it's like that because it will let fine things go through. It'll hold large things out. Definitely a gatekeeper. a door that has a lock on it. These are all good answers. Good answers. All right, so we're going to go.
But how does that really work? Let's check it out. Active and passive transport. Unpacked. Here's oxygen moving across a cell membrane. Here's water. Here's calcium. What do you notice?
All right, so I'm going to play that back again, and then you need to watch what these things are doing. So I'll come back right over here and then watch. There's three molecules. You got oxygen, calcium, and something else.
Unpacked. Here's oxygen moving across a cell membrane.
Oxygen, water. That's the
Here's
other.
water. Here's calcium.
And calcium.
What do you notice?
All right, so take a minute. I'm gonna let it stay right there. What did you notice about when the oxygen passed through, when the water molecule passed through, and when the calcium passed through? What did you notice? Did they all pass through the same way? We'll try that one more time. Let's go back just. Yep, there. We'll start it right there.
Here's oxygen moving across a cell membrane. Here's water. Here's calcium. What do you notice?
Okay, so we got some answers. I noticed they all didn't pass through. Okay, some molecules enter different ways. They have different manner of going through the membrane. Okay, they're doing different things, trying to pass through. Okay. All right. Anybody else want to make a comment? Okay, the calcium stayed on the left. The oxygen goes through the wall. The water has an entrance and the calcium took a toll gate. I like that. That's a good way of expressing it, Natalie. That is exactly what happened. The oxygen went straight through the wall. The water seemed to have a little entranceway, so and then the calcium had a gate that opened and closed. So that's exactly what. So each type of molecule, because they were different types of matter and different sizes, they had different ways of getting through the membrane. Thank you all. Good job.
There are two main ways substances move across the cell membrane: passive transport and active transport. Passive transport requires no energy from the cell. Let's say you're biking down a hill, and even if you're just sitting there checking Instagram, not pedaling, your bike will still move down to the bottom of the hill passively. Molecules naturally want to move down the concentration gradient. That's just a fancy way of saying they move from areas where there's a lot of them to areas where there's not so many. They do this until equilibrium has been achieved and the concentration is the same on both sides. The simplest form of passive transport is called simple diffusion. Very small molecules, like oxygen, diffuse easily across the cell membrane. Other substances, like ions and polar molecules, need a little help to diffuse across the membrane. They enter the cell through channel proteins, which act like an open door in the cell membrane. That's called facilitated diffusion. Osmosis is a special name for the facilitated diffusion of water molecules.
Okay. All right. So unlike oxygen, water molecules can do what? Let me come back over here. So go ahead and answer this one. Do they need ATP to cross the membrane? Do they diffuse easily across the membrane? Do they need a channel protein to move across the membrane? Are they nonpolar or the no answer? Which one? Water molecules. So oxygen is a gas. Water molecule look like that Mickey Mouse structure. How did it get across the membrane? Did it flow through or did it need help? All right. So we might need to go back and look at that again. The correct answer is they need a channel protein to move across the membrane. If you remember, the oxygen just kind of flowed through the membrane, but there was a channel protein that stayed open, and the oxygen flowed through the channel protein. Not like the calcium that had that gate thing that looked like it opened and closed, but water molecules needed, so C is the correct answer. So everybody has switched to that. Thanks. All right, so it needed a channel protein to move across the membrane. Like
Acid
that.
transport works great for maintaining equilibrium, but sometimes cells want to work against the concentration gradient. For example, calcium plays an important role as a messenger between cells. If left to their own devices, calcium ions would naturally diffuse until there were equal concentrations inside and outside the cell. But the body needs much more calcium, 20,000 times more outside of cells than inside them. So cells need to constantly push calcium ions out. To do that, they use active transport. Imagine you're back on that bike, but this time you're biking uphill. You're going to need to sweat a little and be active, using energy to get to the top. For cells, energy comes in the form of ATP, adenosine triphosphate. They need to use ATP to get molecules to move against their natural tendency. During active transport, a transport protein in the cell membrane binds with a molecule from outside the cell. Energy from ATP causes the protein to change its shape so it opens inward, releasing the molecule into the cell.
All right, we got another question. It says, which of the examples is active transport? So again, we're looking at a molecule that's too big to go through the membrane. The cell wants to have it, but how's it going to get in there? All right, we got a couple of people not answering. Everybody needs to, and go with the obvious answer. Everybody needs to answer. I got 25% no answer. Should have everybody answer. Should say 100%. All right, so yes, it is the glucose molecule. Carbon dioxide is a gas, so it'll flow through the membrane. We know the water is going to go through the protein channel, so that's still passive transport. And then the oxygen down here at the bottom. So the only one that is not a gas or water is the glucose molecule. And it's going to have to be pushed through, meaning actively moved through the cell membrane.
So, one of the most important examples of active transport in animal cells is the sodium-potassium pump. This transport protein collects 3 sodium ions from inside the cell. It breaks open a molecule of ATP, releasing enough energy to change the shape of the protein so it opens outward and releases the sodium out of the cell.
All right, I want to pause that there for a minute. We're going to talk a lot about ATP. It's an energy molecule. That's what it is. And it's got an adenosine molecule with 3 phosphates attached. All of those bonds between the phosphate molecules is stored energy. So what she said is breaks off one, and that's like giving it a little battery boost, and then it can do what it needs to do. If it needed more energy, that ATP has lost one, so it's going to go and pick up another phosphate, and it'll be ATP again, meaning triphosphate, meaning it needs 3. So it just gave up one to make this move. It's going to go back and pick up another one and then come to work again.
The pump collects 2 potassium ions from outside the cell, then changes shape again to release the potassium into the cell. It does this to maintain the concentrations of sodium and potassium needed for nerve cell transmission, heart contractions, and other vital functions. Whew, a lot of info. So, to review, passive transport doesn't require extra energy. It's like flying down a hill on your bike. Active transport is like riding uphill. It requires energy in the form of ATP to get there.
Not exactly.
And that's active and passive transport. Thanks for watching.
Okay, you don't have to answer that question, so we're just going to leave that, and we're going to go back to our Canvas page. Malik asked the question, is this like our active sites? That's a good question. No, it's not. So the active sites you're talking about are the sites on the enzymes or on the substrates where the two molecules meet. That's not the same thing. This is actually just an activity. Okay, so either you are, it's kind of like being lazy or just doing something. So the passive means that it just allows things to happen, and active means you have to make it happen. Okay, so that's the difference with this active and the other one, the active site. The active site is a place where, and then there are places on the cell membrane like that too, where they are at what they call active sites, where those are places where the activity will take place, but we're not talking about that. Okay, we're talking about an activity, physically doing something to make the molecules pass through the cell membrane. So again, so we're back here, and you need to, if you haven't written these down, these are vocabulary words, and we need to know the difference between these two. So passive transport, the thing that you need to know about that is, and in general, she talked about the gradient. In general, things move, and let me see if I can highlight this, from high to low concentration without additional energy. All right, so that part is important. Know the rest, but definitely write down the first part. The first sentence is your definition. Passive transport is movement of molecules, it should say across the membrane, from an area of high concentration to an area of low concentration without additional energy. It just flows. Okay. Now, the membrane is called your concentration gradient. Okay. So what it's saying, it's like being in a crowded elevator, and you can't wait till it gets to the floor and some of the people move out because they don't want to be crowded. Okay. They want to go into the room that has low concentration. So they move from a high crowded elevator to a room where there's not too many people. That's going from high to low. And that's a rule. Molecules want to go from high concentration to low concentration. They like to spread out. When we talk about matter, that's what the molecules do. Gases in particular like this because they don't have a shape. Remember, we have solids have a definite shape, definite volume. Liquids take the shape of their container. Gases also take the shape of their container, but they have so much energy, they're going to spread out. You can have a little bit of gas that they use the example of somebody with perfume walks into a room and you smell them in the middle of the room, but you give about 10-15 minutes, person in the back of the room can smell it too, because the perfume gas will diffuse and take up the whole room. So it's going to move from an area of concentration to an area of low concentration. Okay, high to low, that's a rule. All right. So again, notice the gradient. That's a vocabulary word too. Concentration gradient is the cell membrane. Okay, remember that. All right. And then it gave the example of diffusion. Diffusion is anything. Solid molecules, it can be a gas, but osmosis is particularly water. Okay. Osmosis is diffusion of water. So when we talk about general diffusion, that's through your solids and your gases, but when we and other liquids, but when we talk about diffusion of water, it is basically talking it is referred to as osmosis. Okay? So know that as well. That's another vocabulary word. It won't let me highlight that. There we go. So that's a separate vocabulary word to diffusion, but it simply is diffusion of water. Has its own little word. Now, because the water molecule is slightly bigger, it is facilitated diffusion, but it's still passive because all it's doing is going through a wider opening. Other than the little tiny pores in the cell membrane, the water needs a bigger spot to get through, but it still requires no energy. Okay? So passive transport, like I said, is like you just sitting there doing nothing. It requires no energy. All right, active transport, on the other hand, is the movement of molecules, and that notice this is going reverse, from low to high concentration with the addition of energy, usually ATP. Okay, so this requires energy. We want these molecules to be, and we're going to look at some pictures in a minute and start at the top of that worksheet as far as what this looks like. Again, she mentioned in the video, sometimes you have a lot of molecules on this one side of the membrane and you want them to go on the other side, but it won't go because it's already going from high to low, but you want them to go from low to high. So you've got to make them go. So it requires energy. 3 examples, she mentioned the sodium pump, exocytosis, and endocytosis. So we are going to look at this right now. All right, so if you click on these, and you might want to do these. All right, let's do them together.
Observing diffusion. Substances move into and out of cells in a few ways. One method of movement is diffusion. Look at the picture below to examine a simple example of diffusion. What occurs over time as the molecules of purple dye interact with the water in the beaker? Hover over the picture to find out. Molecules are always in motion, random motion. The rate of diffusion is higher in gases than it would be in a liquid. The rate of diffusion is also higher with increased temperatures.
Okay, so that's 2 things that you need to write down. That diffusion is higher in gases than in a liquid, and diffusion happens faster when you raise the temperature. Okay, again, if you back up to your discussion that you learned last year or sometime when you learned about matter, that the states of matter have to do with how fast the molecules are moving. In a solid, the molecules are very close together and they're vibrating ever so slightly, so they're not moving very much. In a liquid, they're moving a little bit faster, so therefore they're not as tightly packed together. They have some uniformity, but this is why they take the shape of their liquid, because they're kind of spread out. A gas has no shape and no volume. It takes the shape of its container. So and to get from a solid to a liquid to a gas, we have to keep increasing the temperature. So if we want the molecules to move faster, we increase the temperature. Okay? All right, everybody with me? All right, so far we have diffusion. What they're also looking at with the when she put the drops of dye in the beaker is that notice let me stop doing that. All the drops went in one spot, and then that's a concentrated area. They wanted to move, so they spread out and they kept spreading out until they couldn't spread out anymore. And we call that equilibrium. Okay, it'll keep moving until it can't move anymore, until it's nice and balanced, and then it stops. All right, next one.
Diffusion occurs down a concentration gradient. Diffusion is the net movement of a substance from an area of
high concentration of that substance to one of lower concentration of that substance, or down a concentration gradient. Click the picture to see what happens to the molecules over time.
All right, so right now,
You've probably experienced this in a room when someone arrives freshly doused in perfume or cologne. Those nearest the perfume smell it first. Then eventually the smell permeates the air in the entire room, reaching equilibrium.
all right, so I mentioned that earlier. All right, so if you look at, I don't know if I can make the picture won't go back unless I. All right, so all of the molecules were concentrated close to the bottle. And I guess they're pumping this bottle. Oh, the stank. Okay. All right. And then when it came out of the bottle, all of the molecules were in one spot, but over time they spread out. And imagine that the room is your container. So they will spread out and fill up the whole room until there's no more space, no place else for them to go. But notice with the gas, they also kind of stay far apart from each other. All right. So again, that went from high to low.
Diffusion across a cell membrane. Water, carbon dioxide, and oxygen are some of the simple molecules that will cross the plasma membrane diffusion when a concentration gradient exists. They would be able to move between the phospholipids from one side to the other, as shown in the picture. The majority of the molecules move from higher to lower concentration, although there will be some that move from low to high. The overall, or net movement, is thus from high to low concentration. Eventually, if no energy is put into the system, the molecules will reach a state of equilibrium where they will be distributed equally throughout the system. Molecular movement is still occurring, even at equilibrium.
Okay. So what she's looking at is let's say the top is one side of the membrane and the bottom is the other side. And over time, the molecules are going to pass through. And so in the center one, you have a few molecules and they're going to keep moving in that direction until you get to the third panel where there's an equal number of those dots on either side, and then it kind of stops. But what she also said is it kind of keeps moving. So if one goes over, one is coming back over on the other side. So there is constant movement, but it's very slow at that point because they're trying to maintain equilibrium. So basically, that movement slows down to a stop once there's an equal number of molecules on either side of the membrane.
Carrier proteins facilitate diffusion. Some large or charged molecules cannot cross the membrane without proteins that help or facilitate diffusion. Carrier proteins embedded in the membrane serve as pores or channels, letting specific molecules pass. This movement of molecules down a concentration gradient by use of a transmembrane protein is called facilitated diffusion. The protein often changes shape, similar to a revolving door or a movable bridge.
Okay, so again, you need to remember that those structures that are embedded in the membrane are called carrier proteins. Some are just a channel, and some act like little gates that open and close. All right, so the ones that are a channel, those are passive. The ones that actually open and close like a gate, that's active. But both are facilitated in that they offer assistance.
Osmosis is the diffusion of water across a semi-permeable membrane. Special technology. Water would move from areas where there is more water or high water potential to where there is less water, low water potential. In this diagram, the solutions in the beaker are separated by a semi-permeable membrane, which is represented by the red line. The membrane only allows the pink water to pass through, and not the solute, which is represented by blue circles. Water potential is higher on the left-hand side of the beaker initially, compared to the right. The solute decreases water potential. Net water movement is from high water potential to low water potential until equilibrium is reached. The resulting volume in the beaker on the right may be different, but the overall percentage of water or water potential on both sides is the same.
All right, so this is where it starts to look tricky because it looks like on the right you have more stuff. But what we are looking at is the volume of water, just the volume of water. Okay, so that's represented by the pink. So the amount, so if you look at the little circles that represented the salt molecules, the number of salt molecules on the right when you started was a lot. And it looked like you had an equal amount of water on both sides, but you have to remember the law that says no two objects can occupy the same space at the same time. So the salt has space that it's taking up, and the water has space that it's taking up. So while on the right side in the first beaker, it looks like the water is equal, it's not an equal volume of water because there's a lot of salt over there. So the space that the salt is taking up means there's less water over there. So we're going to follow the rule that says that the water is going to go from where there's a lot of volume of water to a smaller volume of water. So then you have your second beaker. Now that looks like, it looks kind of lopsided, but the amount of the little circles, the dark circles, that didn't change. They didn't go through the membrane. But now there's more water on that side because we've increased the water volume. Now the volume of water is this, and while it doesn't look like it, the volume of water on the left and the right are now the same. So that's going to be, it's going to stop there because there's equilibrium. All right. So with osmosis, it's a little tricky because you have to look at what is my water doing? And there's always things dissolved in the water. So we're not worried about what those things are doing or what the concentration of that is. We're worried about the concentration of the water. That's why water has its own name for diffusion osmosis, because it looks a little different because there are things dissolved in it. Okay? Questions? Make sense? All right, we're going to keep on looking at this in the next one as well.
Tonicity is the measure of how much water versus solute there is in a solution. If we can identify a solution as one of the following, we can compare it to another solution to predict the direction of osmosis.
All right, the worksheet that you downloaded at the very top, it's got these three things that she's about to discuss with you: isotonic, hypotonic, and hypertonic. So be listening so that you, and all you're really going to have to do is put a check mark in the column according to which one is which. And the last two boxes are going to be that. So don't put any checks until we finish watching the next two. But this is where the worksheet starts, with at the top with these words. Okay, so pay close attention.
Hypotonic solutions are those with less solute. Hypertonic solutions are those in which more solute is present. Isotonic solutions have equal concentrations of substances. Their water potentials are equal, and water would move across the membrane in equal amounts.
Okay, so that gives you definition. So when you need to come back, and this box is kind of hard to do because you have to almost have to play the whole thing over to get it to play again. But that's where your definitions for those words are going to be on this page. Now they're going to give you a visual.
When animal cells, such as red blood cells pictured here, are placed into each of these solutions, we will see the following results. In a hypertonic solution, there would be more solute and therefore less water outside the red blood cells. Water will move out of the cells, creating or shrinking them. In an isotonic solution, there is the same amount of water and solute both inside and outside the cell. Water would move across the membrane. In a hypotonic solution, there's less solute and therefore more water outside the red blood cells. Water moves into the cells, causing them to swell, possibly lyse.
All right, lyse means to burst. Okay, not like lice, like the organism lice. This one means to burst. The other one is LICE. Okay. All right. So let's look at the top of your handout that you downloaded. They've got the 3 words and they want to know what the cell is going to do. So the first one says causes the cell to swell. So which one of these 3 caused the cell to swell up? Well, I just lost 3 people. Hopefully y'all just went to the bathroom. And you can type a message in the box. Which one of these is the cell swelling up? Which one is staying normal? And which one is shrinking? That's what you're looking at. And you're going to want to put a checkbox in that column. All right, again, what we're looking at is red blood cells. Red blood cells are in a liquid environment and they have liquid inside as well. Okay. Uh, got kicked out. Gotta come back. All right. Some folks got kicked out. Yeah, I think the internet is acting weird today. I know I had that trouble at the beginning. All right, nobody's typing an answer in the box. Which one of these is, y'all have to answer the top. Again, we're at the top of your worksheet that you just downloaded, and you want to decide based on that picture, based on your definition, which one is which. Okay. Yeah, I got to let somebody else back in. All right, there you go. All right. I guess the internet is doing very weird things. Oh, okay. All right. Nobody's going to type an answer for me. Which one did you put a check next to for the first one? Causes the cell to swell. Which one looks like it's swollen? Hypotonic, isotonic, or hypertonic? Okay, Ariana and Natalie say hypotonic, and that is correct. Hypotonic, the one on the left, is it's swelling. It's bigger than it's supposed to be. Actually, the cells in the middle are the way a red blood cell should look. The ones on the end in the hypotonic look like fat donuts. Regular donuts, fat donuts. Okay, so what has happened is there's a lot of water, like it's showing you in the picture, going into the cell and the cell is blowing up. Eventually, if it has too much water, it will burst. Okay, so if there's a little pump in there that's going to pump the water out, but if it goes in faster than it can pump it out, it will burst. So hypotonic is when the water is going in and the cell enlarges. All right, it says it doesn't change the shape of the cell. Which one does not change the shape of the cell? The one that says normal. Which one is that? Which one does not change the shape of the cell? Okay, I got isotonic. Thank you, Isabella. Okay, and Piper. There you go. Thank you. And Ariana. Good job. Thank you. So you should have a check mark in isotonic for that. So you should have a check mark for hypotonic for the first one. The second one is isotonic. Now, the next one says causes osmosis. Osmosis simply means the movement of water. So looking at the arrows, the second row, which one has water going in? Or which ones have water going in? So we have two situations where the water is going in. Okay, isotonic and hypotonic. So you want to check mark in both of those. Because if you look at the picture, water is going into a normal cell, but the normal cell is also able to pump it out. So there's kind of an equilibrium going there. But the hypotonic is also allowing osmosis. It's just not being regulated within the cell. So you want to check mark in both of those columns for causes osmosis, and the last one causes the cell to shrink is going to be a hypertonic. And that's the one where all the water is coming out, nothing's going in, so the cell shrinks. Okay. All right. So what I'm going to all right, they do have these two words down here at the bottom. So let's look at that first before we do the matching. All right, so you want to click on the word and it's going to give you a definition. So this one you already have, active transport, the movement of the molecules from low to high concentration with the addition of energy, and the energy molecule is called ATP. So they move against the gradient. And again, the gradient simply refers to the cell membrane. Okay, the gradient says that ordinarily things go from high to low. In active transport, they're going in reverse. All right, clicking on these three examples, you need to know what they are. Exocytosis is the process of releasing molecules out. So you want to think, underline the word exo and then underline the word out when you write this down. So exit means out. The substances are going out of the cell. Now, what it's also saying here is the way that it gets things out of the cell is it collects in a vessel, and then the vessel moves over to the side of the cell membrane and spits it out. Okay. All right. Then you have endocytosis. It's the process of taking the molecule into the cell by forming a vessel. So in other words, things on the edge push in and they create a little pocket, and that little pocket eventually will pinch off and form a vessel and move into the cell. So in this case, when you say endo, think underline into. All right, so endo is going into the cell. Endocytosis. All right, and then the last one she demonstrated this in the little chat up in the video that we watched. She talked about the sodium transport pump. Okay, these are little pumps where the molecules bind to the protein on the cell wall. So that's where that ATP attached itself to the protein channel, and it actually allowed it to open and close and pump things in and pump things out. Okay. All right. All right. So up to that point, so you don't want to do this one just yet. You want to stop and at least use the rest of this time to complete the first part of the worksheet. And there's a couple on the back. We'll look at labeling and the osmosis practice on Tuesday. Okay, but use the rest of this time to do the matching terms, the two sets of matching terms. If your worksheet looks like mine, there's two additional answers on the back. So use this time to do that. Why is mine not showing? All right, you don't want to do the cell challenge before you go. So right now, everything you need is up to here. Oh, we skipped one. Hold on. All right, my page is frozen, but your page probably won't be. Make sure you click on that last circle, because you won't be able to restart it until you go through all of the dots. All right, so use this time to finish that last dot. And when mine pops up, I guess it'll go. But you make yours probably will go. But between that and this one, you should be able to do the matching sections on the worksheet. So use the rest of the time today to do that. We'll worry about the other 2 pages on Tuesday. Any questions? All right, so while this worksheet does have to be submitted, you don't have to submit it until next week. And because we are doing it in class, all the answers should be completed. There shouldn't be any delay when come time to submit the worksheet. I don't know what's going on here. And of course, if you need to go through this little box again, you can do that. Replay it, look at the definitions, replay those. By clicking on the word, it just keeps changing. Getting an image. There we go. Okay, so if you click on these, it'll show you that these are vessels inside the cell, and they're going to move over to the cell, and then they're going to open up and spit out what they don't want in the cell. All right, so that's your exocytosis, things that are going to leave the cell. All right, the endocytosis. Up, there we go. Knew that was going to happen. Let me see if I can go back. Okay, something weird is happening with my computer. But anyway, you all can click on, if I get it back, I will in the next 2 minutes because class will be over next 2 minutes. but you can click on them and look at the second one. Should have shown you where the molecules are outside and then they form a little pocket. And then that pocket is going to eventually close and then pinch away from the cell membrane and bring the materials that it wants inside the cell. All right, I don't know.